All right, so we're going to start off by looking at two formulas, okay, the distance formula and the midpoint formula. And my real reason for this section is the distance formula, because it has a square root in it. Okay, and I want to make sure we remember how to work with square roots. So basically, the distance formula is used if you've got 2 points, and you want to know how far apart they are. So what I'm going to do is I'm going to make a picture. And when they have you do a problem like this, they give you numbers. Okay, the x1, the y1, the x2, and the y2. Just to keep it simple, I'm going to put it in quadrant 1. They don't have to be positive numbers, but just for the purposes of the diagram, it'll keep it simple. So the goal is to figure out how far apart are points A and B. I'm going to take this line segment and I'm going to turn it into something. Okay, and keep in mind you're in trigonometry. So anybody have a guess what I'm going to turn this line segment into? Yeah? Triangle. Yes, I'm going to turn this into a triangle. Okay, and the way I'm going to do it is I'm going to draw a line that way and a line that way. And I tried to draw it. It's not perfect, but does anybody know what kind of triangle I just created there? A little more specific than a triangle.
Right triangle?
Yeah, I made a right triangle. Now, my goal really is to find the length of the hypotenuse in this triangle. Okay, that's my goal. And whatever that is, that's going to be the formula to find the distance between point A and point B. All right, let's just to look at something simple. If you had a number line and you had 2 points on it, what do you do with these two numbers to find out how far apart they are? Yeah, just subtract them. Okay, so pretend like you have a point here, you have a point here, just like having a point here and a point here. It's going to involve subtraction. But does anybody see the two things I would subtract? Because these points have x values and they have y values. If you're trying to find the length of the bottom, you only need to focus on one of those things, either the x values or the y values. Think if these points are horizontal or if they are vertical, which we'll do in a second. Yeah, Jamel? Yeah, you'd subtract the x values. Say the first x value was at 2 and the second x value was at 7. You'd subtract 7 minus 2, and that would give you the distance. So in this case, it would be x2 minus x1. Or you could do x1 minus x2. The order, it's not really going to matter. I'll do it as x2 minus x1. Okay, that's the length of the bottom side. How about the height? How would you find this? What would you have to subtract to do that? This point and this point. I want to know that distance. Yep.
Y2 and Y1.
Yeah, you'd subtract y2 minus y1. You wouldn't subtract the x's when you're dealing with the height. The x's are the same. That's at x2, that's at x2. It's the y's that are different. They're at different heights. Now, if these were actual numbers, you would know the length of the bottom, and you would know the height. Does anybody know how you can find the hypotenuse if you know two other sides in the triangle? Yeah, Justin?
A squared plus b squared equals c squared.
What's that?
To find the hypotenuse, it's that formula usually. So, finding the distance between those two imaginary lines, that gives the right angle.
So what did you just say? Well, I'm not sure what a squared plus b squared equals c squared is. Well, I am, but.
The hypotenuse is the c squared.
Okay.
And then the a squared and b squared is the two other sides. It doesn't really matter the order.
Okay.
And so it's basically the numbers that you find from the subtraction, the x2 minus x1. So it's like that number squared. And
Yep.
that's the same thing with the other one.
Does anybody know what that's called? Yeah. Yeah, it's just the Pythagorean theorem. You take one leg, find its length, square it. Take the other leg, find its length, square it. And that's equal to the hypotenuse squared, which I'm just going to call AB. That's what I really want to know. Now, in order to get the length of AB, the distance between the 2 points, I don't want to know the distance squared. What would I have to do to each side? I would have to take the square root. So I'd have to take the square root of what's on the left. And when I take the square root of what's on the right, this and this cancel out. And there is my distance formula. So that's how you find the length of AB. So it's the difference in the x's squared plus the difference in the y's squared. You add them up and take the square root. It's just the Pythagorean theorem. That's all it is. All right, so some people, they do this, they don't even have to label anything, they just plug it in, that's fine. If you need to label stuff, we can do that first. So how about, Michael, what would you label this? Is it x1, y1, x2, or y2?
That would be x1.
Yeah, we can call that x1. And now that has to be y1. So there's my first coordinate. James, how about the 3 and then the 2?
That would be x2 and y2.
X2, y2. Now, just take those 4 numbers, plug them in the 4 spots in the formula, and you're all set. Okay, so Kristen, what's x2?
3,
Minus, and what's x1?
4.
4. Plus, I usually write that first, so then I just have to fill in the 2 things. How about, Marcos, what's y2? 2. And what's y1? 5. Okay, so now we just simplify it and see what we get. Kelsey, what's 3 minus 4? And then square it? 1. Okay, and Ariel, what's 2 minus 5?
3.
Negative 3. And if you square negative 3? Not positive 3, so negative 3 times negative 3. 9. So square root of 1 plus 9, and that's going to give me square root of 10. And that's it. If they ask you for a decimal, you just type that in on your calculator. If they don't, you can stop right there. Any questions on distance there? Now, this is a problem that there is nothing else to do. Okay, this is a square root that cannot be reduced. Let's look at one where we get a square root that can be reduced. And that's why I did the distance formula, because I wanted you to make sure you remember how to do this. Okay, so example 2, find the distance between those 2 points. 2, 6, and 4, 10. Does everybody have example 1? All right, so Graham, can you start me off with what's going to go in the first set of parentheses? 4 minus 2. And how about the second set? 10 minus 6. Okay, any questions on setting that up? Okay, and Trevor, what's 4 minus 2? 2, and if you square it? 4. Okay, Henley, what's 10 minus 6?
1,
And square it?
16,
And I get the square root of 20. Now, this is not a good way to leave our final answer. Does anybody know why you wouldn't want to leave it as square root of 20? Yeah. Yeah, you can reduce this. Okay? There's a lot of different ways people do it. Sometimes people use like a factor tree, or basically what I do is break it up into 2 numbers. Something times something. So I want to find 2 numbers that multiply to give me 20. And I want one of them to be a number I can take the square root of in my head. So can anybody think of 2 numbers that multiply to give you 20? Like you could do 40 and a half, but I can't take the square root of those in my head. Yeah,
5 times 4,
yeah. If you break it up into 4 times 5, now you've got 2 separate roots. One of them is going to simplify nicely. 2 square root 5. Okay, you probably did that back in algebra, but it is important to make sure you know how to do that. Okay, any questions on that one? And that's the real reason I just did the distance formula, okay, to do that. So if you need the directions for how to simplify square roots, that's how you do it. If you already know that, then you don't need to write it. So you have to factor what's under the root. That's the radicand. So it's a product of 2 numbers, one of which has to be a perfect square, like 4. Okay, 4, 9, 16, 25. Those are your perfect squares. And then I split it apart into 2 roots, and one of them I was able to simplify. The other one I couldn't. So we already did square root of 20. Let's do square root of 48. Anybody think of 2 numbers that multiply to give me 48, and one of them is a perfect square? The bigger the perfect square you can think of, the better. But it's not wrong if you do a smaller one. We just might have to do it more than once. Anybody think of something times something that's 48? Were you going to say something, Kelsey?
I was going to say 12 times 4.
Sure, you can do 12 times 4. That'll work. And then the square root of 4 is 2. But the only thing is, now I'm looking at 12. And I'm thinking, you can break up 12. How does the square root of 12 break up? Do you know? You can break it up as 3 times 4. If you have to break something up twice, it's because you didn't pick the biggest one you could have to start with. It's not wrong, you're just going to have to do it twice. So there's your 12, 4 times 3. And what's the square root of 4? Times another 2. So the answer here is 4 square roots of 3. Now, does anybody see a different way you could have started this problem so that you don't have to break it twice? It's not in your times tables. That's why I'm guessing people probably didn't see this one as easily. Yeah, you can break up 48 as the square root of 16 times the square root of 3, and the square root of 16 is 4. And you're done in one step. There's always a way to do every problem in one step, but sometimes it's easier to just do it a couple times and go bit by bit. Any questions on that? All right, and the other thing that can happen with a square root, and it's not going to happen, I don't think it's going to happen this week, but it's going to happen pretty much every week on from the first, is you can end up with square roots in the bottom. Okay? Let's say you ended up with something like this. If you end up with a square root in the bottom, it could look like 3 divided by the square root of 5. Generally, we don't leave a square root in the bottom. We have to fix that. And from algebra, does anybody know how you fix that? Can leave it in the top, just not in the bottom. Josh?
You multiply both the numerator and the denominator by square root of 5.
Exactly. You multiply the top and the bottom by what's in the bottom. And Jocelyn, what does that give me in the top? You don't have to do a decimal or anything. Yeah, just leave it as 3 square roots of 5. And then in the bottom, the square root of 5 times the square root of 5, that's the square root of 25, or 5. Okay, so you're not going to see this, I don't think you're going to see that this week, but anytime we get roots in the bottom, we always want to fix it so it's in the top. Especially if, let's say, it was a multiple choice answer and you got this after doing your work, I would write that on the test if it was multiple choice. Right, so we'll talk more about that again. That's the other thing that's important with roots. All right, and the last formula we'll look at, this one doesn't have really anything to do with roots. It's a midpoint formula. And the midpoint formula is just used to find what's in the middle of 2 points. Well, let's say from statistics, if you had 2 numbers and you wanted to know exactly what number was in the middle, how do you do that? You have 2 grades, and you want to know what grade is exactly in the middle of those 2 grades. There's a name for it. I'm just not using the name because that's the question I'm asking. Yeah, it's the mean, right? Find the average. So that's exactly what the midpoint formula is. You add up 2 x values and divide by 2. That's the mean of the x's. Comma, and then this is the mean of the y's. It's 2 y values added together and then divide by 2. So that's the midpoint formula. Average the x's, and then average the y's. So I think it's even easier than the last formula because you don't have any square roots, and the worst decimal you're ever going to get is a 0.5 because you're going to be dividing a number by 2. So it either goes in evenly, or you get 0.5 as a decimal. Does everybody have the top part? Suppose you have. Okay. Okay, so take a second on your own, see if you can find the midpoint between those 2 points. And if you get a decimal, you can write it as a decimal or leave it as a fraction. All right, so let's take a look. Okay, again, as I went around, the one mistake that I saw a couple times is people subtracted instead of added. Okay, so just make sure this one is adding the x's and the y's. Okay. So Graham, what do you get when you add up your x's? Yep, 3 and 7 gives me 10. Okay, I'll deal with that in a second. How about Becky? What do I get when I add my y's?
17.
Yep, 13 and 4 is 17. And we can simplify 10 over 2 definitely to 5. 17 halves, if they don't ask how you leave the answer, I don't care if you write it as a decimal or as a fraction. Okay. What is 17 over 2 as a decimal? Yep, 8 and a half. Okay. So that's the midpoint. What's the difference between the kind of answer that I got in example 1 and the kind of answer I got in, I think technically that was example 4. What's the difference between those answers? Yeah, Gabe?
One of them has 3 points.
Okay, well, what is that called?
Graph.
Yeah, the answer in example 4 is a location. It's a where can I find something. The answer in example 1 and 2, this is not a location. It's something different.
So in the first one, you're finding the distance between 2 points, but in the fourth one, you're finding the point between those 2 points.
Yeah, this is a length. It's how long is something. Midpoint is where is something. It's a coordinate. So just make sure you understand the difference between the kind of answer. Okay, okay. Any question on the midpoint? All right. All right, so the homework tonight and most nights will usually be in the book. If I do a worksheet, what I generally try to do is put the worksheet in the video. So if you are absent, you can see the worksheet that everybody got in class. All right, so on page 7, 15 to 21, just the odds. Those are distance problems. 39 to 43, odd. Those are midpoint problems. And these 4 are not in the book. Okay? Copy down these 4 square roots and simplify them as much as you can. Okay, so we'll take a look at that first thing tomorrow.